Hello and welcome to the part 1 video of the payload fuel optimization for a round trip using machine learning. This video is just educational purposes, and it's just based on some simple words without concerning about some real world scenarios to just give you an idea of how we can use machine learning and artificial intelligence and modern data driven methods for analyzing our airline operation, optimizing the routes, optimizing the fleet management of an airline to make more income for your airline just without knowing a lot about their operation using machine learning. These are some new methods, and in this video I'm going to show you the first steps to make your hands dirty and know more about it, and to just motivating you to use these new modern methods. The final goal of this video is to optimize a round trip for an airline with just in a specific type. For example, from city A to city B, you have a round trip, and the fuel price, the ticket price, the operation price, and anything is different between the city A and city B. So you kind of have some very complex scenario here. Although it seems simple, it's complex. Which one has more benefit, to sell all the tickets, sell all the seats, and just make your tanks full in the city A and again refuel and in city B and come back to your base? Or no, just for example, if the fuel price is more expensive in city B, you can sell less seats and just save some money and save some fuel and don't refuel on your destination. Or maybe you want to sell less seats on the way to the city B and without refueling sell more seats and more tickets on the way back, because maybe the ticket from city B to city A is more expensive and will give you more benefit. So as you can see, the problem becomes complex with adding these features. So you can expect to have a closed form solution for that. This is when the power of machine learning and artificial intelligence comes to play, and combining it with optimization methods such as genetic algorithm or pattern search, you can get very great results, and in a matter of seconds you can find the global maximum of your airline's income profit in a specific route. This is what I'm going to show you in this video. The first step is to know how much fuel we're going to use. We're going to create a data-driven model using machine learning methods such as support vector machine, using regression learner of the MATLAB. And we should select which features are important for us. For example, the payload, the ticket price, not the ticket price, the field elevation, the distance, and so on. After we know we have a good fuel estimator, then we are facing with an optimization task. The first step is to define our objective functions and income, define the constraint, such as you definitely have some constraints such as maximum takeoff weight, maximum landing weight, the zero fuel weight, or maybe the number of seats you have, and so on. So then you need to define your optimization problem and then solve for global optimum. This seems simple, and it is really simple with MATLAB and what MATLAB brings to you. So in this video we're going to show you the steps ahead. And again, I'm going to say it is for a simple world scenario, so you need to make your specific problem for your own airline. In this first part, we're going to focusing on the first item, which is fuel estimator using machine learning. What we're going to do is we're going to gather some data from our airline. In this example, I've gathered about 5,000 flight records for the last year and filter it and remove some outliers and remove some noisy or maybe abnormal flights that I'm not going to take account for them, such as maybe a diverted flight or maybe an abnormal flight or maybe an emergency or anything like that. I'm going to remove it from the data. I have about 4,000 clean data for a specific type, and then I'm going to create a regression learner app based on some limited number of features such as takeoff fuel, payloads, origin and destination, the distance, field elevation, and so on. And I'm going to walk you through all these steps in this video, so stick to the video and let's analyze our airline income. Okay, now that we know what we are looking for and we know the steps, now you have an idea what would be the intermediate steps and what we are going to do in this video. So let's dive into the works and just I'm just going to walk you through the steps so you can do whatever you like with this example. And I'm just going to repeat it again. This is just an educational purpose video with just some simple world features and not implementing some real world constraints. So for your own application, for your own projects, for your own airline, you should add your own constraints, your own cost functions, your own features based on your data you have, based on the amount of data you have. So you might need to change this based on your project. Okay, I've uploaded the initial version of the source code here in MATLAB File Exchange. You can go ahead and download it from here, or you can use the MATLAB add-on explorer. Just go ahead and click on the add-on explorer and search for maybe Airline Payload Fuel Optimizer or anything like that. You can also get it from GitHub. All the links are in the description below, so you can download the codes here. And if I tend to update this later on, I will put the release version here. Right now it's 1.0, and if I'm gonna update it, I will update it in the release section. Okay, after you download it, you can go ahead and open your MATLAB and open the directory of the plugin. You will find 2 folders and 2 files. The apt.mat file is auto-generated for you, so you don't need to change it. You can and you only need to change the apt.xlsx or the Excel files. Let's open it. Depends on your airline or your project. You might have some limited number of airports in your routes and your in-fleet routes. So you can put it in an offline file like this. For example, the IATA code of the Kilo India Hotel Airport is Oscar India Bravo Kilo, the elevation, latitude, longitude, which is the Kish airports. And you can, if your airline has lots of airports and flies to lots of destinations, you can use an online query. You can query online from many sources out there. You can just send the IATA code and get the ICAO code, and you can get the elevation, latitude, and longitude using, for example, SkyVector API or any other APIs, or Google Earth even. You can use the data online or you can use it offline, just like what I did here. So depends on your airline. Go ahead and put your airline destination codes here. Let's see the folders in the Explorer. You have 2 folders here. The first one is fuel estimator, which is going to be covered in this video, and it is the first step. So we are going to create a machine learning based model with data, with only data, knowing nothing about the performance of the aircraft. And in the second step, we're going to optimize a round trip. So it will be covered in the next video. So let's open the fuel estimator. You will find a bunch of files here. For example, the get distance, get elevation. Let's open it here as well. This function, you're not going to use this function. It's going to be auto called from the main file. Just for your curiosity, you can see, for example, the get distance, just get the airport codes, first airport code, second airport code, and you're just gonna calculate the nautical mile distance from this using the special parameters in the MATLAB, or the get elevation and so on. Let's close this all. The main file that we're going to use is the main MLX files, and there's another file here which is fuel and time. This is going to be your main data. So I've just copied the 10 items for you for the examples, but depends on your airline. You might have tens of thousands or thousands of records here. The more data you have, the better output you have. And remember, the more good data and not corrupted data. There is a very popular quote about it, and it says garbage in, garbage out. So if you have 100,000 of data that are not reliable and lots of missing data, lots of corrupted data, you won't get a good model. So remember to have the maximum number of data you have, but the good data. You need to process the data and pre-process and remove the outliers. So you have the columns such as aircraft type, registration, flight data, airborne time, off-block, on-block, the payloads, the passengers, estimated flight time, the actual flight time, and so on. It depends on your airline or your project. You might have some other records as well, or you might don't have some of these items. Depends on your project, you're gonna change it. So put your data here and then you're good to go. The code will auto-generate and auto-process this file for you. Let's switch back to MATLAB and see and open the library script main.mlx. Okay, in the first step, we are gonna import our data, which is a spreadsheet import option, number of variables. We're gonna import the airport list, the apt.xl file. So you can see there are 26 airports here. And then we're gonna import our data, which is our real data. I just added the column names here. Remember this is auto-generated. I haven't typed all this code. I've used the import option of the MATLAB is import data. So I'm gonna process the data and put, for example, I said that the date time feature, the aircraft registration is a categorical, and so on. So I haven't typed all these codes. I used the auto-generated function from the import data. The nice features of MATLAB. And then this is the data. This is a full version. It has more than 5,000 data. And most of the data has the aircraft type of MD-82, and some of them are Airbus A320 and Boeing 737 or Embraer. After that, we have some pre-process options here. For example, you can specify the types, simply, for example, the MD, or maybe, let's see, Airbus A320, and it's going to switch to about 200 flights with Airbus A320 in this sample file. Or you can process in all the data, in all the aircraft types. Because in our project, we want to calculate the fuel, so let's not change it. Let's change it to a specific type. If you have tens of thousands of data from, or maybe thousands of data from each type, then you can just go ahead and create a general model for all your aircraft types, because you can teach your model that it can automatically correlate between aircraft types, so you don't need to specify the aircraft types. But here we have only about 4,000 data of the MD-82, and our data set is not organized, so we have 4,000 of MD-82, 200 of Airbus A320, so it's not going to be a good model. So I'm going to specify the type model. Then you can filter it by the airport 1 and airport 2. For example, you can specify a specific route, for example, the Ika airport of Iran to maybe Izmir airport, I guess. Yes. We have 8 items with the MD-82. It's actually more data here, but I have cut the data and just shorten it for you here. But let's put it, for example, into all, and we're gonna have again the 4,000 data here. Again, if you have lots of data from uniform data from all your aircraft register, you can filter the specific registers. For example, you can specify it, for example, Tango Alpha Lima, or just go ahead and select all the registers. And that's it. Now we want to add some other data to our data sets. For example, in our data sets, we didn't have the distance, the field elevations, the day of year and hour of day, or payloads. So I'm going to calculate those and put it on our initial data. Distance, I'm going to use the get distance, field elevation, and so on. The day of year is very important, especially in the country that I live. We have a very hot summers here, so the performance of the aircraft in the summer is not even close to the performance of the aircraft in the winter. And field elevation might also not be important for your project, but in my country we have airports up to 5,000 field elevation, and on the other hand we have some airports with 0 field elevation and also minus or below sea level airport elevation. So field elevation is a very important aspect for my project as well. Then we're going to calculate the payloads, which is the number of adults, children, infants, based on your company or your project policy, and the used fuel, and so on. Okay, if you have some outliers, you can come here and just see yourself with the stack plot. You can have a good idea of if you have an outlier or not. You can filter the outliers here. You can use the outlier toolbox from the MATLAB, the task. And maybe, for example, you see that you have a general flight from Ika to Istanbul that takes about 3 hours. You have one record that is 10 hours, or maybe 30 hours. So definitely this is just an outlier or maybe typo error. So you can find them easily here and remove that from your model. After that, the full data file, which is here, the full data.map will auto generate it for you. So after each time you run this code, it will auto generate for you. And then the next step is to really predict and teach our model. Let's just run it to make sure that everything is loaded. Now we're going to use the Regression Learner app in MATLAB. You have different options here. You can use the neural network learner, or maybe not classification, but different options here, for example. But the best option right now in 2023, the best one to use for your project is Regression Learner. It has all the features you need. SVM, I don't know, the simple regressions, cubic, optimizer, PCM, everything you need about artificial intelligence and machine learning is already available for you here. So this is your only home, your first and last home for regression tasks. Just go ahead and create a new session from workspace. And it says what are your imports. So I'm going to say my imports is, this is data. It is about 4,000 records with 47 columns. And it's going to automatically select all the features here. And remember, up until now, the date time, it's not yet supported by MATLAB. But you have the categorical, double data, and so on. If you have, again, I'm going to repeat it, if you have lots of data, you might even want to input the aircraft type or aircraft registration inside your model. But now I don't have that option, so I'm not going to use all these options. I'm going to remove all and we'll select which items I want to have them here. Let's see what we have selected here. The items that I've selected for this educational video are the block time, flight time, day of year, distance, field elevation 1, field elevation 2, hour of day, payload kilogram, and total weight. Actually, the difference between total weight and payload is our empty weight and fuel and these things. Block time and flight time, the difference between two specifies the taxi time. Remember to put some indirect features inside your feature list. So not only you have the flight time and block time, now you have the taxi time hidden inside your features as well. So I'm going to select the block time, fuel time. Let's have total weight, payload, hour of day, day of year, field elevations, distance, how many distance, field elevation, hour of day. I think that's all. Yes, that's all. And it's gonna ask you what is your output, what are you looking for, and we are looking for used fuel kilogram, which is inside our data. Okay, next step is to protect our model and training task from overfitting. If you don't know what is overfitting, it's when you have some sample data, you're going to force the model to learn the features inside your model that is not the real world scenario, that's more maybe noise or the wrong data. So you're not going to fit exactly to the sample data. Your model will know everything about your sample model, but it will fail with real world data. So you're going to protect it from overfitting. You have different options here. Holdout validation is good when you have really huge data. So you can hold out maybe 25% for validation. If you don't have a huge number of data, go ahead and use the cross validation. You can improve it, for example, 10 validation folds. And increasing these validation folds will increase your learning time as well. And I always used to use these test data as well. I use 10% of data always for my testing. Depends on your data and how much you're sure about your data. You can select more or less for your test data. Again, validation will be used inside your training task, but test data is completely put aside and will be only used after the learning. So you're not going to use this inside your validation. You can think of it as maybe the exams and quiz you get from your students. The validations are some quizzes that you take from students meanwhile the terms going on. So you take a quiz from a student, you tell them that you don't know, for example, the specific topic, go ahead and learn it and come back again. This is a validation. But the test is the final exam. You will take a final exam from your student. You will tell them that you are 60 out of 100, and you won't give them another chance. You either accept them or reject them. You're not going to give them extra chance. So this is the final item here. After you have selected everything, let's start the session. You have everything you need for your data inside this real beautiful panel. The PCA is just totally another video, but it's a very fantastic item. Just gonna show you the topic. You can, if you don't have an idea from your data, you can use the feature selection options and see how exactly your features affect the data. For example, let's use the MRMR. I don't know the scientific principles behind this, but it will give you an initial idea of, for example, what affects your output the most. For example, you have 20 features here, and you're going to select maybe top 5 of them. So you're going to use this feature ranking. You can see that distance has almost the most important effect on our used fuel, then the block time, total weight, and the least effect is for the payload, and after that the day of the year. It's interesting to see that out of day is even more important than the day of year and payload kilogram. There are different tests here, F tests, different principles. And if you want to just put one step ahead, you can use the PCA. PCA is another topic and it's beyond this video. So, but I'm just going to introduce it for you. And the MATLAB does everything for you. You don't need to know anything about PCA. You don't need to know the scientific principle. You're just going to enable the PCA. And for example, you say, okay, I have 9 features here, but because of my limitation in calculation, I need to have only 2 number of components. It will automatically calculate the effect of each component, and it will create some new features. For example, it's going to create a new feature, 2 features, for example, feature 1 and feature 2. And this feature 1 and feature 2 together can actually show all the effects, almost all the effects of all these 9 components. This is magic. This is magic of mathematics and changing the axes and coordinates and this kind of things, that it can just describe the final effect of maybe 100 features to maybe less than 5 features. Or you can just make yourself, relieve yourself even more and put explain variant and say, okay, do the best you can and just describe the 95% of the effects of these features in any number of components that you can minimize it. For example, I have 200 features, minimize it to any numbers you can to just describe or explain the variance to 95%. It can, depends on your data, it can be minimized to 2 items, 5 items, 10 items. And just for your own curiosity, I ran the PCA on this model, and it says it can explain 95% with only 1 component. It's very magic and important. But in this education, I'm not going to use the PCA here. But you don't need to do any extra step. Just go ahead and click PCA, save and apply. Just for demonstration, let's do one of them, for example, the linear SVM, and train it and see how it will work. It said it is using PCA, and the feature selections here, let's see what's happened. PCA, it is taking much more time. Let's use the tree here. It's important, it says that it is keeping 1 component only, and it is explained the variance to 99.9% with only 1 feature. So that's great magic of this PCA. So you can go ahead and use the PCA in your project or not. PCA is good when you want to implement your model on a limited resources, so you need the minimum number of features here. Okay, and this is the SVM version as well. Again, it says it's only keeping 1 component here. Okay, let's disable the PCA and see the next steps. Next step is to select which item, which methods you're going to use. Each one of these methods is a total topic in your data science or machine learning courses in university. But here you can only just click on it and it will do all the magics for you. If you have a good processor, you can go ahead and select all or all quick to train. Let's select all, and it will automatically, did I disable the PCA? No. I'm gonna disable the PCA, and all. There are also an optimizer option. You can, some of the models have the capability to be optimized. For example, the cubic Gaussian SVM can, the hyperparameter can be optimized, but I'm not gonna go beyond this and make this video boring. After you select this, all you have to do is to click on this train, and all of them will be trained. If you have a multiprocessor core or you're using a network with cloud computers, you can use the parallel, you can enable the parallel to train this in parallel. I'm gonna click on train, and it will automatically start to train, and you can see it will automatically use all the resources here. Let me, it is training all of them. You can see almost all of my cores are working pretty hard to train all these models. MATLAB is a magical tool for any engineering. Only using all cores in your computer might be a headache for you, but MATLAB does it for you without knowing exactly what is happening. Okay, I'm gonna fast forward the video here for you, and we'll come back to you when the learning process is finished. Okay, as you can see, all the models have been optimized and evaluated. Maybe, I don't know, less than 2 minutes or so. The minimum RMS validation based on the validation data is the SVM, which is about 2 tons of fuel. I personally don't trust on this validation because of my data. I know that my data are very separated apart. You can see, for example, here, as you can see, let's use the plots, for example, predicted versus actual. The more your data are aligned with this line is the best your model is. As you can see, most of the data is pretty good aligned, but we have a lot of outliers here, which are some of the flights that have been delayed, some of the flights have been rerouted, some of the flights had some emergencies or maybe abnormal procedures. These are these items. So actually my model is not that bad, it's very good. It's pretty good. Or you can use the residual plot here. The more your data are correlated in this zero line, or came together around this zero line and are uniformly distributed, is the better your model will be. But I am more interested in my test data. Remember that we hold 10% of our data aside for the testing. That data is more important for me. So I'm gonna say, okay, test all my data on all the models. Let's say test all. This is much more better values here because our test data, there is a smaller chance that some emergency or abnormal flights be available in that 10%. Again, the best item is almost this SVM model, yes. Support vector machines is very good in these applications. So you can see the RMS error is less than 400 kilogram of fuel, which is perfect. Remember, we haven't used any equation here. We haven't used very good equation. We don't know anything about our aircraft. We don't know about our engines. We don't know about aircraft types, the routes. The most important item is that we don't know the destination, and we haven't implemented any constraint or equation based on our field elevation, distance, and the model automatically detect this and trained itself. You can use the actual predicted versus actual on the test data, as you can see it's pretty well uniform around our data, and there are some abnormal data as well, but usually the data is, for example, let's use the residual. Usually the data is around this margin, and it has only about 100 kilogram of fuel. This is perfect. Okay, now we have a model. We have a model SVM. You have different options here. You can export the plots just for showing your boss, showing your stakeholders the plots you have or your reports. You can generate the function, then that function will automatically do whatever we did inside this app. This is a great feature. This code, as you can see, put all the options here that we did, and we even have no idea what it is doing. For example, just for demonstration, the kernel scale is 3. I don't know, A K fold is 5. If you remember, we put it on 5. The items here, the PCM is off, and so on. But we don't need this one as well here. We want to export our model. Again, we have 3 options. You can have the compact model, the model for deployment on a specific hardware, but we are going to use it inside our computer, so we're going to use export model. All you have to do is to give it a name, any name you like, okay, and the model will be automatically generated inside our workspace. I have it already here. The trained model is here, and it's automatically trained. Now that we have trained our model, we go to the next step, which is the SVM model here from our main MLX file. I have created a simple GUI items here for you: black time, flight time, day of year, hour of day, payload, total, and it will automatically estimate the fuel for you. And remember, if you want to do the training and if you want to do the evaluation and testing, just tick this one, and it means that I have already trained the model. And the model that I'm going to use is this one, SVM3 full, and it's already available for you inside the folder. You can use the model that I have created here, the exact steps that you see in this video. You can use it on your own project. This model is already available here, and it will automatically load it for you. If you have ticked this item, check this item, it will automatically load the SVM3 full.mat, and it will automatically load the trained model for you. Then the fun part begins, the black time, flight time, and other features. You just ask your model, you say, okay, train model, predict this specific flight for me and how much fuel does it burn. You go, for example, the black time of 100, flight time of 80, and so on. And you just have to click on this. I had some typo and missing items here, so I paused the video and fix it for you. I'm going to show it to you again. Now you have a simple GUI here that you can manually add the features value and automatically predict it from your train model function, and will automatically predict your fuel. Remember one important thing, you can't go ahead and type any numbers you like. The numbers should be around and in the same range of your training data. So if, for example, all your training data black time was about maybe 60 to 120 minutes, you can't expect your model to predict, for example, a 40-minute flight or 3 hours of flight correctly. So you can't trust your model. You can only trust it inside the regime, inside your data distribution. So let's, for example, change this item for about 100-minute flight. It burns about this item. Let's change, for example, the total fuel to, I don't think we get a good number here. Maybe the payload will also be less. And let's see if the numbers change. A little change. So you cannot trust it. But if you have real data, you can go ahead and add data from your Excel file here and change and see how your model predicts. This is not what we are looking for. This is not our goal. This is only for debugging. The next step is something else. Okay, in the next video, we're gonna use this model. We're gonna use the model that we have created here, and we're gonna use it for optimizing for a specific route, the round trip. We're gonna find the best item. This is gonna create my cost function. So if you are following this video up until now, remember to subscribe on this channel and like this video to make sure you won't miss the next video, which is using this model for optimizing our task, which is our next part on this folder. Up until then, have a nice time and good day.